When we are called to do an experiment, sometimes it's a very short lead time. We get a 12-hour call and we're in.
My advisor and I, we have to work together. He's talking to the astronauts, I'm talking to the cadre, and so it's really difficult to take it all in.
Very nice, very good. Try not to break them up, but that's a very good disturbance. And now back and forth the opposite direction.
What's funny is I forget who I'm talking to sometimes. I'll have conversations where it's like, oh yeah, we had an experiment yesterday. It was on the space station. We were talking to the astronaut, Doug, and it's so casual. And it's like, most people are like, what do you do?
Throughout this season of NASA Explorers, you've seen what it takes to send science to space through the eyes of one team of researchers. But they aren't the only ones. For 2 decades, the International Space Station has hosted science from thousands of researchers across the globe.
The importance of the ISS to the research community is huge. From the very basic phenomenon of taking gravity out of the equation is that the ISS is really the only platform we have right now that gives you access, long-term access to a microgravity environment.
You can do the experiments, on Earth, but those are almost a precursor to, okay, now let's remove gravity and see what happens. Does it change?
If you're like me, you're a scientist who's trying to unravel the mysteries of science, and someone shows you a shiny new tool, which is microgravity, which can, make science different. And different is what we constantly shoot for.
And different can take time. Before new scientific discoveries could be made, we had to transform an orbital outpost into an orbiting laboratory.
In the early days, it was so focused on building, constructing station and making things safe. And then we started stepping up the number of hours a week that we can use crew time for experiments and research.
That was a very exciting time. The space station would have more capabilities for science. They would have more equipment up there. They would have, freezers, glove boxes, microscopes, etc. Things that we could use to extend the scope of our science.
Space station became a laboratory. It lent itself very well to this concept of fly an experiment, you get the results back, just like you would be in your own laboratory at home. You get more questions as well as answers.
And during that time, a lot was learned. A lot of surprising things were learned. And with that knowledge now, we're developing experiments that are much more advanced in terms of their engineering application.
It's been an extraordinary journey to watch over the past 20-odd years how this has all kind of come together and become, I wouldn't say routine, but accessible. And that's a really powerful thing.
The same thing that gives us new insights also creates unique challenges. Microgravity changes the way everything works, including science.
Working in space, as you can imagine, has a lot of challenges. Everything has to be compact. If you're gonna send something into space, it has to be small. And how can you fit an entire lab bench worth of science into something, your size of your hand? And yet, we still get great information. We still, are discovering things, all the time, and I think it's incredible.
Up till the NASA twin study, I was an Earth investigator. The biggest adaptation that I had to make was, on Earth, there's an ample supply of all the tissue that you need, whether you need blood or you need urine. So we had to work together and figure out a plan on how to use 1 vial of blood instead of 10 vials of blood. The stress of these precious, this is the most precious samples I've ever worked with, was kind of novel.
There were different students that all got together to create this project. It was really stressing on every review because, of course, you're they're gonna say everything is wrong and they're gonna blame it on me or whatever. We knew that it would be difficult, but everybody that jumped into the project pulled through. And at the end, we achieved a successful mission. So I think that's awesome.
What we've learned from more than 3,000 space station experiments is helping us back here on Earth and on our quest farther into space. to the Moon and Mars. These experiments are aiding drug development to fight diseases like Alzheimer's and Parkinson's. We've learned about combating bone and muscle loss, which could assist people suffering from osteoporosis. We've tested how to grow plants in microgravity, a critical component for feeding future space explorers. None of this would have been possible without the astronauts, the humans living and working aboard the International Space Station.
Having the astronauts there to help us was a critical part of being able to do more complicated science, to get higher science yield out of the science that you were doing. They were incredible as people who were there to troubleshoot your experiment should you need anything.
You can never replace a set of human hands. I don't care if it's on station, on the moon, on Mars. There's just something that people can adaptively do that you'll never get a machine to do.
You can collect a lot of data with robotic sensors, but there is still a very big role for humans to play in being able to make on-the-fly decisions.
Yeah, that has a little bit of a bubble on the end. Do you want me to force that out?
If it's possible, if you think you can do it with the tip, yeah, we would appreciate that. At this point forward, this is our DNA to sequence, so the most we can retain, the better.
It was rewarding to be able to put my hands on and know that we're doing productive work. Sometimes we get thrown a curveball and something goes wrong.
Station, Huntsville on 2 for TJ and ABRS.
So now they go, all right, we got to get you to go into the guts of this thing. Go find these 2 wires. Have you ever seen those scary movies where the bomb diffuser says, whatever you do, don't cut the red wire? That's kind of what it feels like. You've got somebody who's spent their life developing the research that you're working on, and you're about to go into the guts of his experiment, trusting you very well to do the right thing and not cut the wrong wire. But that's the kind of stuff we need to do when we start going farther and farther away, when we start encountering anomalies we didn't think were likely. And so the crew has to be able to be adaptable to be able to do that. And that was really exciting and fun to be able to accomplish.
TJ, we copy that, and who would have thought a blown fuse would make so many people so happy?
Jeff happened to be orbiting and looked outside the window and saw this eruption just happening. And then he said, hey, I wonder if anybody knows this volcano is erupting. And so he actually called the USGS and said, hey, I see a volcano erupting. Do you guys know about it? First, he had to convince them that he was actually who he was and was actually calling them from the space station. But once you get past that, they then confirmed with other data, like, well, you're right, it is erupting.
So I think those are some of the ways in which the astronauts just play an incredibly valuable role when they're up there helping us with the experiments that we do.
These past 2 decades of microgravity science, they're just the beginning. The start of humanity's continuous presence in space. And the impact of the research in this novel environment is already being felt around the world.
I think most people would not realize how impacted their life is by space. There's a finite number of experiments, but that is a finite number of experiments in a very, very smart community that's very good at sharing the results. There is a real sense of the betterment of humanity in space. You know, it's one place we can all really collaborate and all really get along.
I think it's safe to say that microgravity has allowed writing several new textbooks.
And the more we have more and more scientists working in different arenas to help inform this science, I think the better it will be for the safety and health of the astronauts and the people that follow. We are just at the tip of the iceberg. We have a lot more information that we're going to find out, a lot more information that we're going to need to find out in order to get us prepared for long-term exploration, as we humans are always excited to do.
Space Station now is acting like a test bed, a proving ground for new development, new system hardware, as well as how we're going to be doing research and what kind of research we want to be able to do in a near environment, 240 miles above the surface, versus seriously long distance away where there's time delays up to half an hour-ish that we need to be practicing for, and now's the time to be able to do that.
You know, I would say before I started working at the lab, it was kind of an abstract idea, and there was always the joke about, oh yeah, humans will go to Mars, and it didn't really feel real. And now it feels real, and what's incredible is, you know, I will have a piece of that.
I like to think that some of the work that is being done on the space station lays the foundation for us to be successful on another planetary surface. Will I ever get there? No, it's not likely. But I do hope that someday that somebody thinks back on, wow, it's really great that we learned about X, Y, and Z things from the pollen furrow research, because we'd never be successful on Mars without it.
We'll learn more and more the farther and farther we go. The first stepping stone, though, is the proving ground that we're calling International Space Station.